So same idea as the last question, except now we have originally a parabola, x squared, as our function. So to find the x-intercepts, again, we make it equal 0. We don't need the splits because there is no difference between positive 0 and negative 0. And here we need to solve this equation. We have a couple of options. Easiest one in this case would be factoring. Since this factors easily, we need two numbers, multiply to negative 8 and add to negative 2. That would be negative 4 and 2, so x minus 4 and x plus 2. Split this off to solve it. We get on the left that x equals 4, and on the right that x equals negative 2. Just in the interest of space, I'm going to do the table of values on the next slide. So what we have is we have an x, we have our function without the absolute value, and we have our function with the absolute value. This table is going to be slightly different. Because we have two x-intercepts, this has actually broken the graph into 3 sections. So we're going to have an x-intercept at negative 2, I'm leaving a couple lines above it. X-intercept at 4, I'm leaving a couple lines in there, because we need points in each of those 3 regions. What we know is that when we plug in negative 2 for x, we get 0. Same when we plug in 4. So now I can go to the calculator. I can type in that function, x squared minus 2x minus 8. I'm going to go to the table option, so second graph. And we can see we have some of the table we need, but not all of it. So before we get too far into this, I'm going to select my points. On the x-axis to the left, we'll go negative 3 and negative 4. In the middle, it doesn't matter. I'm going to go 0 and 2 just to evenly space things. I could have picked 1 and 0, or 1 and 3, or 0 and 3, as long as I have a couple of points in between there. As well, I'm going to pick 5 and 6 on the right. So all I need to do to find these values, I just need to scroll through the table, so I'll go up to get to the negatives. So at negative 4 we had 16. At negative 3 we have 7. At 0 we have negative 8. At 2 we also have negative 8. Scroll back down to see 5 and 6. We get 7 and 16. Applying the absolute value of 16 stays 16. Absolute value of 7 stays 7. Those negative 8s, when we apply the absolute value, we get 8. As well, 7 and 16 will stay as 7 and 16. To graph the function, we need x and our y. So just go back to the graph. First point at negative 4, 16. Now this goes off the graph the way it is, so we will need to scale the graph. I'm going to do 2 for 1. So go to negative 4 and go up 8. Because if we're doing 2 for 1, 8 would be 16. Go to negative 3 and 7 would be 3.5 blocks. X-intercept at negative 2. At 0, we had 8. At 2, we also had 8. X-intercept at 4. Got a point at 5, 7. And 6, 16. keeping in mind what this graph was before we applied the absolute value, it was a parabola. So this graph will not be connected with straight lines, it'll be connected with curved lines. So the outsides, just like a normal parabola. The inside piece is just like a normal but upside down parabola. So there's our graph. Question C, the domain and range. Well, domain of any parabola is any real number. Absolute value doesn't change that. The range of the parabola, lowest place this goes is 0, so y greater than or equal to 0. Piecewise function, I'll just do on the other slide for space. So we're going to have y equals, we have our regular function, and we have the negative of that function. We have the regular function anywhere that didn't require us to change signs in the absolute value. So that would be anywhere if x was less than or equal to -2, as well as if x was greater than or equal to 4. Second half of the function, this is where we had to change the values due to the absolute value. This happened in between two numbers, so we can't just say x is greater than or x is less than. We have to actually say x was between -2 and 4. So the way we do that is with what's called a compound inequality, putting two alligators in the same one, and putting x between -2 and 4.